but it's my fault. I didn't say, hey Steven, can you start filming?
Well, was it your fault? I thought I pressed recording like when you were actually like talking about the test.
We had a little miscommunication.
Yes.
Alright, it's okay. It's alright. Alright, in part I, when has the particle traveled farthest to the right? Well, I'm going to check my endpoints, of course. And I'm going to check my candidate if I have a candidate. And I think there is a candidate for when I've traveled farthest to the right. And that would have to be, where would I maybe have traveled farthest to the right?
4.
Everybody okay with t equals 4? Right, at t equals 4 my velocity changes from positive to negative, so that's how I would know that it's a candidate for going farthest to the right. I'm going to go through, I'm going to evaluate what's my displacement at 0, what's my displacement at the candidate, what's my displacement at the endpoint. I'm going to compare all of those, and I think it's going to be greatest at time t equals 4. Okay, and the last one, like I need you to write an integral equation. At what time t have I traveled half my total distance? Well, if I do an integral of the absolute value of v of t from 0 to 12, that tells me the total distance I traveled. I only need half of that, so I'm going to multiply by half. And then over here, that's where I'm going to say, all right, let's do the integral from 0 to little t of the absolute value v of t dt. Everybody okay? Carmen?
Would you not change? Oh, because so you wouldn't. The big T is not the same as the little T.
Big T and little t, it's okay. Those are different t's. Those are okay. Everybody, you okay with this? Feeling good? All right. All right. Penguin Island. I'm definitely going to pick that up right now. I want to give you guys a grade on that. Majority rules on this one. Do you want me to walk through the solutions, or do you just want to turn them to me? Majority rules. Walk through, walk through.
Walk through.
Sounds like walk through. You're like, we just love listening to you. Ramble on and on. Alright, Penguin Island. I had those. Where did Penguin Island go? Where are my penguins?
Present.
Oh good, oh my little penguins. Was Penguin Island on the problem set?
Yes.
Ah, that's... Uh-oh.
Here, I
Where am I?
have to keep.
Oh, I got my penguins. Got my penguins. All right. Penguin Island, and we're filming, right?
Yes.
All right.
No.
So, let me just separate these. Okay, let's make sure I'm looking at the right one. All right. Sorry. All right. Part A, you've got to find d prime of 5, 41.218. Had the calculator do the work. The meaning, at t equals 5 years, this is the rate at which the penguin death rate is, sad for penguins, increasing. They're dying faster than before. 41.218 penguins per year. 2 points for that. All right, B, the integral from 1 to 10, 0 to 10, b of t dt. What does that have to represent? Why on earth would you be multiplying by 1 over 10?
Oh, that's the average.
That's the average, okay? B of t is the rate that penguins are being born, so how fast they're being born. The integral then has to be, in total, how many are born. That 1 over 10 turns it into an average question. So this represents the average birth rate measured in penguins per year for the first 10 years, or you could say from t equals 0 to t equals 10. And then you do your Riemann stuff. 1 over 10, b of 1.25, b of 3.75, b of 6.25, b of 8.75. Grand total 1,368.914 penguins per year dying is the average. How many of you guys came up with the number answer?
Wait, hold
For part B, 1,368.914 penguins per year.
I'm dumb. I moved the decimal over.
Oh, sad panda. Or sad penguin. Alright, C, B of 0 minus D of 0 is 750 penguins per year. This is just the difference between birth rate and death rate. Alright, D at t equals 40. I bet you guys all did really well on this. 100,000 penguins to begin with, plus the total number of penguins that were born, minus the total number of penguins that died, gives me 133,058 penguins. And on this one I wanted it rounded, right?
Yeah.
Okay,
No.
we're not going to have
Yes.
zombie
Oh, yeah,
penguins,
yeah.
that's disgusting. Alright, and if you wanted to, you could combine these into one integral, that would be okay, because the limits of integration are the same. Did anybody do this as one integral? That looks like no. Okay. Alright, on, what is this? Using one definite integral, create an integral equation which can be used to determine the penguin population. So that's part E. E 100,000 plus the integral from 0 to t, b of x minus d of x, right? Doesn't have to be x, could be anything. You could go with one integral, you could go with two integrals. Works for me, no problems. Have we figured out integral equations? We're good with that? Friends over here? Alright, part F, this was the one I did it slightly out of order, and it asked for the average rate of change. So you could say penguin population at 40 minus penguin population at 0 over 40 minus 0 to get 826.439. Or you could say, well, what's the other way that we find the average rate of change of the penguin population? You integrate both functions, subtract them from each other, and divide by 40. I think this is probably the less obvious way to go about doing it. You did it that way.
I did it.
That totally makes sense. That's how all your brains would work. All right, and then of course part G, have to ask a question like this. If I don't ask a question like this, I didn't write a good question. And what did I want?
Max and min.
Oh, max and min, so I want both this time. So we find the candidates, endpoints, and intersection point, 34.657. Then tell me number of penguins at time 0, 100,000. Number of penguins at time 40, I think we already did that work once. Number of penguins at the intersection point, 139,166. Absolute maximum population is 139,167 penguins. Absolute minimum population, 100,000 penguins. Everybody okay? Like, the Penguin Island was good to you all? Alright, if you could put that in the middle of the table. And now, challenge by choice for the rest of the period. We've got 35 minutes. And I want you to decide how much of a challenge do you want in your life. If you want to go a little bit crazy, in the student packet, it's lesson 85. It's called the fuel problem. A year or so ago, Miss Blakely at East End and I went to a PD session, and the PD session was interesting, but not super interesting. So what we decided to do when we got off task was write the hardest question that we could come up with that involved multiple rate functions. So if you want to see the hardest question Miss Blakely and I could come up with together, then it's on pages 50 and 51 of the student packet. And what I'm going to invite you to do is just move to the side of the room. I've got my solutions. You can work on that with as many people as move over there. Who are the folks that are going to do the fuel problem? Okay, Stephen, Polymon, Celeste, Carmen, Ile. All right, why don't you guys move over there? Everybody else, you're going to move over here. And what we're going to work on is the brand new review questions for Unit 5. So Myra, you're going to work on the brand new review questions. David, Giselle, Andrew, and Lewis, you guys are going to stay with me and work on the multiple choice questions? I'll move my junk out of the way. Alright, so all of these questions that we're going to work on over here, and we're going to keep filming, came from the most recent AP exam. This is one of the best ways you can possibly study for the test, is just to work through these problems, make sure that you're comfortable with this. Myra, why don't you join the young men in the back of the room? They will be thankful for your assistance. Alright, so here's what I'm going to do. You guys get 4 minutes to work on the following problems. The only person that you get to work with is the person that is sitting with you right now. You are going to need to move at some point. Right now, in round 1, you guys are working on problems. Where are they? Okay, round 1, questions 5, 84, and 89. 5, 84, and 89. And if you read the question, it'll tell you whether it's calculator inactive or calculator active. I would think you guys can solve all three of these in 4 minutes. Okay, friends over here, I'm coming. Okay, so here are my solutions. Feel free to go through these. It is possible there is a mistake issue. I hope that is the case. Also, it's possible because there's a little note from me to redo the solutions. So, ABC, EFG, yeah, I think there are extra questions in here that aren't actually. I was going to read this question. Deliberately. And there's actually, like, there's nothing to do here, unfortunately, the box is yeah, but part of the PD session that we attended was on having kids like develop their own visuals, and so that we meet kids, the first thing I asked them to do is to actually like read through this problem, draw what's going on. You've got all manner of things going on. Careful. There's a variety of questions like that.
Do you teach this like entire problem during an AP class?
Right, and that's why I said student.
Oh,
So this would be like a lesson that we would be going through. And for you guys, this is just practice.
But it takes 2 hours to load every single
You're right. This equation is for unloading. It's how many minutes.
All right, so the folks working in the multiple choice, you got about 1 minute left. The goal is to get through all three.
How it enters and then how much they take.
So Lewis, it's just number 30th.
So it's equal to
Liz, where do you need to sign?
I do. It's saying it's measured, this page measures in minutes. It takes 2 hours. Yeah.
Okay, friends up front, how many? Okay, you guys are most. Oh, annihilate these are your corrections, okay? Giselle, correction. David, did you not get a chance to pick one out?
I ain't complete.
looks like for Stephen, are these corrections over here?
Or we're saying plus.
Oh no, that's
Whoa.
that's your physics.
Oh, mine's 15.
Wait, what? Oh wait, no, these are corrections. Carmen. Okay.
So you're just, I think it's 500 plus.
Stephen, you did corrections on this one as well?
Yeah, I'm gonna do correct. Wait, that's what we just passed it out.
Okay. Hi there. Alright, so looks like you guys are done. No idea, sorry. Sorry, we're close, but not that way. Alright, so for friends up here, if all went well, question number 1, does everybody have C? If you don't have C, it's C, but we'll start next to that one. Okay, number 84, so the second question should be D. Okay, and then the last one should be D. We're feeling good with those? Okay, obviously you guys made some mistake in the first one. But. Alright, so let's regroup the partners a little bit. Okay, you're going to get another 4 minutes for another handful of problems. We're going to have some movement here. Ooh, we could do like boys against the girls. I know how that's going to end. Always. Alright, round 2. I want you guys to do questions 11, 76, and 89. These are on page 33. 4 minutes.
You mean page 3, right?
Page 3, sorry. So I'm not jacking anything up here. Okay. So the purple, those are your corrections? Okay, Penguin Island, that's what you're turning in. I've got Andrew, Penguin Island, I've got Lewis, Penguin Island, I've got Myra, Penguin Island, I've got Talimon, Penguin Island, Celeste. Okay, and then Celeste, I've got corrections for physics and the fundamental theorem of calculus. Correct. Can you get me the original though, so I can? Okay. If you can just get those for me. Okay. All right. So what was the circle place on Friday?
At first, I was thinking Negro AFT, but then
Less.
I gave literally the amount of captions. It's not really a rate.
Exactly, because AFT is not a rate function, it's a total function. It's just saying in total you have this many, so you don't integrate that.
The second one.
Right, you integrate the second one because the units there are telling you this is a rate function. It's like gallons per hour, whatever it is. So that's where you would integrate, but the other one don't integrate.
Oh. Yeah, got it.
I know.
I forget to look the other.
Louis, did I give you that signed paper back?
Yeah.
Okay.
You got these?
Yeah. Yes.
On the first one,
Mm-hmm.
I got 4,317. You got 3,417.
Okay.
I got 2,000.
Ah, crap! What did I do?
Is one of us having a dyslexic moment?
No.
Huh?
You got these.
Um,
And then these ones are Just can't wait.
You guys done?
You're done.
Okay. Yep. Alright, you're done, but you guys are still working, right?
Yes.
You guys are still working? Were you on the last one?
Yes.
Okay, good. Good, good, good. I'm always amazed by how many new ideas there are with the definite integral. It's just like, world explodes. And all these new things that we can do. Love this one. Almost as much as I love the next one.
What's the next one?
The next one is when we actually get to learn all these integration rules. So like all this stuff that we're doing on the calculator, you don't need the calculator anymore. And so we get to like solve problems the way Stephen likes to solve problems. Because Stephen's a little crazy. Alrighty, so if all went well for number 11, you came up with E. Okay. Number 76, D. And number 89, D. Are we good? Alright. So no problems, no issues. It's time for a challenge. Here comes the challenge. Good luck with this one. Alright. Question number 86 on page 2. I just want to tell you, when I first did this problem, I got it wrong. And then I did it again, and I got it wrong. And it wasn't until I did it for the third time that I finally figured out what I was doing wrong and I got it right. So let's see how many of you are smarter than I am here, because I did this one again and again and again and kept getting it wrong. So I'm going to give you guys 4 minutes just for this one question, and then we're going to switch gears. I'm not trying to sabotage it. Just want to see something.
P90 minus 8.
Okay.
Oh, yeah.
And it gives you how much.
So you do the A prime.
Yeah.
Because
That answer
Yep. Okay, thanks.
They actually entry lines.
We switched it.
well, I mean, technically, it's one thing because
Oh, yeah, but
The exiting is.
the answer will tell you the same thing you need to feel like what the sign means.
because when it says like they're taking away, for example, they're taking away 50, where they're taking
It's decreasing. Oh, yeah. No.
Yeah.
To just say,
How about the other one?
even at 2.
So it's just that first one that we're doing. That's fine. Okay, so thinking about the friends at home who are watching the most boring video ever. All right, let's get some feedback from you all. All right, I want the value of b so that the integral from 0 to someplace b has to be equal to 0. So, could b happen anywhere between like 0 and this guy here? Could the value of b be something less than 3? Why not? Why can't it be less than 3, David?
Because all the areas possibly it won't equal to 0.
Right, from 0 to anything before I get to 3, it's all positive area. Even at 3, it's all positive area. So in fact, and you guys can find exactly what the integral is from 0 to 3 of f of x dx, and I saw a lot of you guys did that. You said, all right, this is pi times 3 squared divided by 4. Lewis, did you get a decimal for that?
Yes.
What'd you get? 7.0686 is the area of this quarter circle here. Everybody okay? What I need is I need that area over here to be equal, but also opposite. I need to know where do I draw the line so that the area comes out to be this negative 7.0686. That's really the thing. So what if we try it? Yeah.
I got D because I set that equal to 1/2
No, the average amount of
B plus 3.
Okay, so you've got a triangle over here. Specifically, you've got a right triangle over here.
So multiply times 2, that times 2, and then square root that, and then half 3.
Whoa. Okay. So I heard you say all the right things, but is everybody okay? The goal is to get a triangle over here that has an area that is exactly negative 7.0686, or the negative of 9 pi over 4. So if I'm going to deal with a triangle, well, to find the area of a triangle, I need the base, I need the height. So how long is the base? We don't actually know how long that base is. But let me call it something like, I don't know, like, A, I want to avoid B because they're already using B for something else. Do we know anything about the height? Whatever this guy is here, the height has to be the same but going in the negative direction. And the reason is they told you that your line segment here has a slope of -1. So however far to the right you go down the exact same amount. Well, how do I find the area of a triangle? It's 1/2 times the base times the height. So I need this 1/2 a squared, or I guess the negative version, to be equal to negative 7.0686. And then you said you're gonna double, you're gonna take a square root, you're gonna do all those things. So a squared is like 14.1372. A then has to be, what's A?
3.7.
3.759, and 3.759 is really close to 3.760, so it's A, right?
No.
Myra, why is it not A? Okay, you're like, no, that's just stupid. What does A represent? David, what does A represent?
That area there.
I'm sorry, yeah, sorry. This A over here represents,
Just this part.
A is how long this side is, but where does this start? It starts at 3. So the B value that you need is what you get by doing 3 plus that guy over there, which is this guy. So how many of you guys honestly had D? One person? You guys had it? No, you didn't have it? 2 people? Andrew, you're like, it's Friday before Thanksgiving, leave me alone. Everybody okay? So the first time I did it, what I started doing was I said, okay, like all this was good for me, and I said, okay, well B, if this is where B is, then the length of my base is B minus 3. It's the difference between B and 3. How far down do I go? I go down negative B, and then I think I was just getting myself all turned around. I had a half, B minus 3 times negative B was this 9 pi over 4. I was all over the place. The fact that any of you get this right on the first shot, way to go. Seriously tough stuff. Alright, so let's move on to the free response. Alright, free response. Also from last year's AP exam, you're going over to the very last question. I'm going to give you guys a little bit of time to get this set up on your calculator, give it a good read, mark this sucker up. Since Polymon's otherwise busy, I'm not going to graph it on the calculator and project the calculator. I just want to see what you guys can do. All right, friends over here, how goes
60 to 240.
Okay. So what's the one that I didn't do?
D and E.
I didn't do D and E?
Right, it skips those two.
Oh, you're right. These I threw in. Okay, so let's just talk through this. If I'm integrating from 10 to 60 a prime of t dt, what does that do? What is that? The amount of gallons in the tank?
Like I was thinking, like did you do this?
Yeah. A is A the total amount of gallons in the tank?
No.
A T minutes is modeled by the function of T. Okay, so A of T is a total, right? So it's saying in total how many gallons went into the tank. So A prime is telling you how does that rate change? How does the total number going in change? When you do the integral of that, you're going to then be back to total. But you're looking at the difference between 10 and 60. So if you use fundamental theorem of calculus, you're looking at A of 60 minus A of 10. And get whatever the number is. 5,033.909 gallons. So it's you can say it's the number of gallons that are used, right? A of 60 is how much you had times 60. A of 10 is how much you had times 10, so that would work. And then this guy down here, want the integral, infinite number. So you figure out the length of each rectangle, which is going to be 50 divided by n. And then it's going to be A of 10 plus 50 over n. There's one thing here I don't like. You get the same issue.
50.
The 50 over n is the width of one rectangle
So
times k, because that's where you're going to say, oh, the first one is from 10 to 10 plus 50 over n. The next one is 10 plus 50 over n to the next one. Nice. Yeah. And so it's F and G that I've done, right? And it's labeled instead of F and G. Okay. So the current price of gas is 55 gallons. So you can start at 8 a.m. or 9 a.m.
4 hours.
But P of T. P of T is 8 a.m. So if we're going to look from 9 a.m. until 12 p.m., that's not going to be 0 to 180.
I don't get it.
It should be from 60 to 240. because it's a 3-hour
I think it'll
interval
be
that you're looking at, so
It
it's
says
180
kilograms and
minutes
then it's
later.
being dollars.
How many kilos do you have?
Okay. So you're going to integrate from 60 to 240. And what are we going to integrate? P of T, because P is the rate that the cars are using the gas. And why are you going to have to fill it up?
Yeah, I think you just
Yes, we're not
Yeah.
put it up, because they're on 2 separate intervals.
Right. P is defined differently
Which bank?
on that first part of it.
Oh, so it's from 60 to 120
Right.
plus.
All right, the good news is you guys all pretty much had it set up as like $2.59 times the integral from 60 to 240 of P of T. And that's great, but because P of T changes the way it's defined on that interval, you have to split the integral into 2 different intervals. Okay. Okay, David has left you all, so that must mean that things are not going well over here. Have you guys all had a chance to do part A? No?
You don't get it.
You don't get it, okay. All right, so a company produces and sells, oh my God. Does it say child powder? We're not selling child powder. That's disgusting. Chili powder. I think later on it actually becomes chili powder,
Yeah.
not child powder.
Makes sense.
Oh, sweet Jesus. The company's weekly profit on the sale of X kilograms of of chili powder is modeled by P. So P is the profit in kilograms. A, find the rate in dollars per kilogram at which the company's weekly profit is changing when it sells 32 kilograms of powder. At what rate is the company's profit changing? They're asking for a rate of change, which I would hope would tip you off to something. Rate of change in a calculus class always means the same thing. It means the derivative. So you need to find the derivative of that function at 32. And then they go on to ask you, is the company's weekly profit increasing or decreasing when you sell 32 kilograms of chili powder? How on earth are we going to make a decision about that? Right, if the derivative is positive, then the weekly profit is increasing. If the derivative is negative, the weekly profit is decreasing. And what are we getting? 65.32? 92? 62? Okay. But the important thing there? Okay, then they told you it would have to be,
So actually,
it should be, what,
should be
18.
dollars per kilogram.
Yeah.
What's the number again?
Okay, probably the easiest way to go and take the derivative would be to like type in the function for like F1, because maybe you're going to need this again, and then go on the calculate screen, find the derivative, plug in 32, and I think the answer is 65.920. Okay? So 1 point for the number answer. Now, what's the conclusion? The weekly profit is increasing when the sales are 32 kilograms. That would be the second point. Okay. Part B, how many kilograms of, oh, it's child powder
Because you're
again,
gonna do A.
must the company sell to maximize its weekly profit? What are we doing here? It's an absolute maximum. Now be careful, you want the absolute maximum of P of X. So in order to find the absolute maximum of P of X, you're going to have to look to see where does the derivative change from positive to negative. That's going to be your candidate, and then you're going to evaluate at the endpoints.
split it up 3 times, right?
Yeah.
Because you're going from 0 to 40.
Right, instead of this one is the fundamental introduction to question. Because you need to consider how much was in there. And you get to consider how much they put in.
I put
And you get to
48
consider how much
squared.
was taken out. So it's all the things. So yeah, this is how my brain works.
Rewarding.
4 hours, that's correct. It would be 240, that is correct. However, that's the problem.
2 hours for the little one.
Right, the other truck is only putting gas into the tank for 2 hours. So by the time 11 o'clock rolls around, they're done. Or really leaning question. This is not the kind of thing I would expect you guys to do on the test. The goal is just to push you hard.
So that's only 8.
Okay, so if you guys can just make sure the solutions come back over where the notebook is. So this 58.358, is that the candidate? Okay. Okay, perfect. So it starts off life as the candidate because this is where P prime changes from positive to negative. And what you guys are telling me is it's the absolute maximum because something else happens. It's the only time where this change happens. There's only the one time where there's a change in P prime, and that goes from positive to negative. Now, one thing before the timer goes off, the first time I looked at this question, I was like, wait a second, they want me to maximize P, and I have the graph of P in front of me. There's a way to do that. There's a really easy way to do that, which is just graph P, and like do that like analyze maximum feature on the calculator. That's not an allowed calculator feature on the test. The things you're allowed to do with your calculator on the test, find roots, find derivatives, and integrate. And intersection points are okay too. So I was surprised that they wrote this because I can imagine some calculus student saying, oh, let me graph the function on my calculator, and where's the maximum? And they just like use the calculator. The reason why they don't give credit for that is that that's not actually calculus work that you're doing. You've replaced the idea with calculator work. Yeah. And I bet you get the exact same answer. Right, it's the exact same answer. The problem is they're not going to award you the same amount of credit for an answer like that. All right. Wait, does your idea, is that what you look like without while here?
It's right. Well, they black when I was resting.
Oh my God, I just would not ever look at this picture and be like, oh, it's David. I'd be like, I don't know who this kid is.